You
This
might want to stay
conference
here.
will now be recorded.
All right,
Okay.
everyone. This is part of our February rolling into March business challenges and chiplets. I had three speakers scheduled today. Unfortunately, two had personal issues. Tim from Microchip has been nice enough to present, and then next week we'll have AMD and Marvell, and I think we wrap up after that. So, Tim, all yours.
Good morning. So first off, I just want to start by introducing myself. So Timothy Pizarro, and I'm a senior product manager for Microchip, and I work for our it's the Data Center Solutions division, and I'm in Burnaby in Vancouver, Canada, and maybe just as a background for my interest in chiplets, it stems from the our division. We are our focus, our target market is the high performance computing, and therefore we are constantly challenged, or we're pushing the limit of what technology is able to offer us. And so that's why we are looking to chiplets to help us solve the problems that we're facing. And so Bapi invited me to speak to you today. I don't have a whole bunch of slides. I have one slide precisely, well, two, including the introduction. And what I do want to say is, if anybody wishes to interrupt, please don't hesitate. I'm happy to speak. I'm an extrovert, so I'm going to speak as long as you let me. But if you do have questions, don't hesitate to unmute yourself and ask. And for those who don't wish to speak, I'm guessing there's a chat option. I can see a chat option there, and I would invite Bapi as the moderator to interrupt me with any Connect questions that come up on the chat, and I'll do my best to answer them. Now, what I wanted to talk about is what I qualify as some chiplet industry business challenges. I speak on behalf of Microchip, but these views, I think, are generally applicable to the industry. Of course, they're an opinion, so they can be disputed, and I welcome that. I welcome that conversation. I'm not here to say that I'm the absolute source of truth. I'm not. And that actually leads to my first line item, which the business challenge we face in chiplets today is, I believe, is a great deal of ignorance, and that's not a pejorative. So it means that so if you look back at the history of like 100 billion years ago, when I started in semiconductors, that I worked for a company called PMC Sierra, and we actually had what we called a MCM, or a multi-chip module, and which we did productize. It was an OC12 line interface, or STM1 line interface for optical networking and transmission networks, and we brought that to production, and we sold it, and then for a short period of time, it was quite successful. The problem that we experienced with the multi-chip modules is we were never able to keep up with the monolithic process improvement. That extra step of building a module, it never worked. And so I do believe one of the things that we have, you might say, in the chiplet space today is perhaps a hangover from the MCM days. Everybody remembers the MCM failures, and we've always been saying, yeah, no, it's not feasible. Now, of course, we do have the stalling of Moore's law, which is why chiplets have come to the fore again. But still, you have a general, what I would describe as an ignorance of throughout the market as to what chiplets have to offer. Now, we do have pockets of expertise. I'd like to highlight my coworker, Anu. She is a chiplet expert. So, she is a center of excellence and intelligence on the matter of chiplets, and I'm counting on her to come step in and correct me when I make mistakes today. But I would characterize microchip and the industry in general as being quite ignorant about what chiplets may have to offer today. And it, that's not a cause for despair. I think this talk, for example, is one of those initiatives, and Bapti, of course, by having them, in terms of changing the circumstance of ignorance about what chiplets might be able to do for us. So that's my first point, and that does, I mean, it's a very general point. You're going, yeah, it's what's the expression I'm looking for? I can't think of it right now, but it's perhaps a platitude. But I think it is a real challenge. It's a real business challenge, because if you go to the people who hold the purse strings, you've got to do a lot of justification before they might consider chiplets. And now there are some exceptions to that. Oh, sorry, go ahead. There's a question.
Yeah, Tim, actually, I have a comment about that one. I mean, I respectively do not agree. I mean, I don't like the term ignorance. I think a lot of people are aware of the benefit of the chiplets, but then also we're aware of the limitation of the chiplet. So I don't think it's in ignorance what chiplet can provide to us. It's really that trade-off, and making the right trade-off is more than kind of in ignorance from different industries or company. I mean, that's my personal feedback on this one.
Sorry, that was Salem, was it?
Yes.
I'm just letting. Thank you for that, and I think I'll politely agree to disagree. And the point that I would make is, I'm a big part of that, and from a business perspective, is from the senior management who controls budget. I do believe, from a business perspective, it is a challenge to get them to consider chiplets because of ignorance of how the industry has changed now. And I was going to make a caveat there. So, and I welcome, if you want to interject, please don't hesitate, because it's an interactive conversation, and I welcome interaction. But the point before you do interact, I would just say, is there's some very major exceptions to that, and they're the big three, which I like to describe, which would be, of course, Intel, AMD, and NVIDIA. And I'm very pleased to see, without calling out individuals, that we have at least one AMD representative today, and I think they may be able to agree with me on this. Those companies, because of their business, what they do for a living, it's a no-brainer to do chiplets. Like, it's just an absolute no-brainer. And I think that, because basically they cannot build what they're building without chiplets. They just can't do it anymore. What they need to do, and the scale of what they need to do, they can't fit it in. They don't fit in the reticle. It just doesn't work for them. In order for them to be able to deliver and meet the demand of the HPSC, high performance computing business, they must use chiplets, and so they've mastered it. The reality is, the rest of us in the ecosystem, we're still able to do a lot in monolithic, and that actually may come back to the point that you were making, which is there is a lot of awareness of perhaps within the technical community of what chiplets might be able to offer, but we're saying no, it's not helpful for us at this point. And the cost benefit. So I would like to make a call out again to my colleague Anush, and her and some of other industry teammates put together a spreadsheet that helps you analyze whether or not to go monolithic versus chiplet. And so there is this public model. It's available on the OCP site. I probably should have put a link in here to it, but please, if anybody wants to know where that is, they're welcome to connect with me, and I'll direct you to the right place. But the point that I'm trying to make here is, there's still a lot that can be done in monolithic for a very large portion of the vendors that are supplying the HPC market, and that has to do with the fact that what we're trying to do just doesn't have enough gates to make sense. And so again, because of the extra step that chiplets present, you know, you've got to do some atypical packaging. You've got to, you know, you have to have an interposer, you have to have a particular substrate design. It's an extra step, and it's complicated. I'm not suggesting for a moment that it isn't possible or technically possible, absolutely, but just from a business perspective, you know, you don't want to throw an extra step into a design because we're always challenged for schedule. So you know, why make anything more complicated than you have to? So I guess that would be my point about the cost benefit versus monolithic. For many applications, monolithic is still the dominant best solution, except for, as I mentioned, you know, the big three, where it's and perhaps others. I'm not trying to say that the big three are the only ones that have this circumstance, but they're a prime example of, and for the rest of us, I believe that very often monolithic does the job. Now, the other part of the business channel or business challenge is third-party chiplet availability. And so if again, please interrupt me if you have something where you want to interject. I welcome that, and please don't hesitate if you want to make a point or you want to disagree with me. Third-party chiplet availability. Now, you know, when you drink the Kool-Aid, like I was at the Chiplet Summit, I had the good fortune to attend there, and it was a great event. It was very informative. I think it was a great harbinger for a lot of progress for the development of chiplets and availability of chiplets. However, if you went to each individual, you know, because there was not only were there technical presentations, but there was also like a exposition of different vendors presenting what they were able to offer, and all of them, or not all of them, but many of them had chiplets that they are going to bring to market. But that's the key word there. They are going to bring them to market. And if I woke up Monday morning and said, I want to buy a chiplet and I want it to be shipped to me, and I want a delivery on Friday, I'm not going to get it, right? Because they're not available. And I'm not trying to. It's just a fact, right? Like, I'm not trying to be disparaging about it, but it's just the reality is that they're not available. Everything that you do right now with chiplets, with some exceptions, of course, with some exceptions, is quite speculative in the sense that it's just not available. And that is a business challenge, because from a business perspective, business does not like risk. Business is averse to risk, and you are constantly making the case. You know, think about all the business cases that you've presented to your management. What is one of the, you know, the manager, the person who's managing the purse, one of the first things that they're worried about is, well, what are the risks and what have you done to mitigate them? And so that availability represents a risk, and that's a business challenge. And I guess the other part that moving on to the fourth point, which is the project schedule uncertainty.
Wait, I have a question here for.
Please come back.
For a company, sorry. For a company like yours.
Yes.
If you shift to chiplets, or if you do a partial shift to chiplets, whichever one it is.
Yeah.
Is the availability of third-party chiplets a significant factor, or is it like AMD where they just shifted their product line to chiplets?
Yes, you know what, Bappy, that's an excellent question. And maybe the detail that I'm not presenting or expressing, the detail I'm not expressing is that if one of the arguments for chiplets, which is an excellent one, it's a really excellent one, which is, I have IP, it's in a chiplet, it's been tested, it works, and even if I wasn't pushing the reticle, there is a benefit to incorporating that chiplet because it lowers my risk, right? And it lowers my cost, and it could actually save my schedule, notwithstanding the fact that maybe doing the chiplet packaging is an extra step that I lamented. So third-party chiplet availability certainly isn't the, yes, indeed, if we were outside the reticle, or if we were outside in the yield, and it was really important for us to do chiplets internally, then we would, and that the third-party availability would not be a consideration. But to just again go back to the big three, that's why they do chiplets. Well, why do they do chiplets? Well, what the chiplets they're doing are basically they take their cores and they put down like whatever, I think it's 4 or 8 cores or something to that effect, or AMD. I'm going to get the details wrong, so please reference the right sources to get the real detail, but the accurate detail, I should say. But there are multiple cores. The IP belongs to AMD. They define the interface that goes to their IO chip that is in the middle, and so they're not waiting for outside IP in order to do that, but it's because of the size, the magnitude of the parts that they're doing that is breaking the yield model. That means if you try to do monolithic, either you can't do it because it's too big, or your yield is so terrible that you want to break it down, but you own everything there. You have control of everything there. You do everything there. And so sorry, did that answer your question about why we would have why third-party chiplet availability is such an important factor to a microchip in terms of deciding to use them? Did I answer your question?
So I guess I'm asking, it is, you know, some companies move to chiplets for sort of making it easier to make more SKUs, others to move for extra large design. Yes. And both of those don't necessarily depend on the availability of third-party chiplets. They're sort of internally driven shift towards chiplets. So, are you saying your designs are small enough that that's not enabling them?
Sure. So let's talk about the SKU case. The SKU case can be addressed by die variant and fuses. And you can do a lot of that without needing to go to chiplets. That's what I would say. Yeah, I mean, that's what's been done. Sorry, let's be even more. There's there's fusing, there's die variants, so separate tape outs, but much lower risk, right? Because if I do one part and I've seen the IP, and you know, the scenario is you tape out the mega variant, and then you do subsequent tape outs, or I guess some people like to call them stream outs of other variants. But because you've done the mega variant, the minor variants are, or let's say the major variant and the minor variants. The major variant has cleaned the pipe for the minor variants, and so you can do a bunch of SKUs at a lot lower risk. And then of course there's the fusing options, and then there's another option, which of course is binning, right? So you might bin, and that also gives you SKUs. So there's a lot of very, very tried and true, let's say, practices to get SKUs that doesn't require chiplets. Although the SKU argument for chiplets is a very important argument, and I'm not. It's we will see much more and more of that all the time as the chiplet technology becomes more accepted and more prevalent, more ubiquitous. Let's just use that word. Sorry, did I answer your question now?
That did, yes. That actually straight on, because it gets back to Trent's question from a couple of weeks ago about the business case. So thank you.
So then the other thing is project schedule uncertainty, and it is, you know, we are always under a tremendous amount of pressure on schedule, and anytime you introduce something new, of course, you know. We already, like, it always amuses me enormously when you are in that meeting, the big meeting where you got all of the senior management and you've got some major project, and You know, they want to know how much time it's going to take to do something. And, you know, in general, everyone can say, yeah, we know, you know, it takes today in 16 nanometer, you know, you can do a chip and tape it out in 18 months. And I'm sure there'll be some people out there who will go, no, I can do it in 12 months, or I can do it in, you know, but the reality is, you know, something in 16 nanometer of reasonable size, it's gonna take you 18 months. I'm sorry, I don't care what you say. You're not gonna. It's a law of physics thing. You know, if you're doing something with 200 million gates or 300 million gates, they're just some laws of physics that are gonna make you run into that. However, whenever you're innovating, I mean, innovation by its definition, you're facing problems that you don't know how to solve. And when you are trying to develop leading edge product, by definition, you're trying to do things that haven't actually been done before. And so there's this tremendous uncertainty about, oh, well, will we really be able to do it in that amount of time? And if you're not pushing the edge, then you're not now you can be a fast follower, or you can be a bottom feeder. That's not in our division. That's not our operating mode. You know, we are trying to be always on the edge, and consequently, there's this schedule uncertainty. And chiplets just right now add a schedule uncertainty that makes you say, well, you're more comfortable going back to monolithic if you think you can do it monolithic, because like I said, you're in that big meeting, you don't have to talk about some extra risks by going to chiplets, which will change. It will change as we become more familiar with it, and the risks have been better addressed and better understood. And you know, I'll out of ignorance, because I made that point in the beginning, I'll just give you some examples. Like in packaging, when I start putting, you know, if I'm trying to do 3D and I got to do, I think they're copper pillars, and I mean, I don't, what's my, our parts, you know, we have a demand for high temperature. Am I going to meet, you know, is this packaging going to meet my thermal requirements? Because I have to have a fit rate, which is, you know, I'm going to just throw some number out there, which is probably wrong, you know, 10 to the minus 8 or something like that. It's probably too high, but it's too low. But the point I'm trying to make is, you introduce this new stuff, I'm not going to be able to qualify, right? I'm not going to be able to go to production because I don't meet some of the boring physical characteristics of the packaging that is creates uncertainty, which has to do with introducing a new packaging technology. So that's sort of, I'm trying to provide a specific example of what might introduce schedule uncertainty. I have a new tool flow. I have you know, all of the things that were addressed in that summit. You know, there's testing, like, okay, I stacked 7 die on top of each other. You know, how do I test it? What's you know, I got to go to manufacturing. I need a reasonable yield. How do I know what that yield model is going to look like? That introduces uncertainty, and it's not just necessarily getting to prototype, it's getting to production, because we're talking about business challenges. And so not only do I have to make a product, but I have to make a product that makes money. And so there's a whole bunch of, you know, outside the fact that I didn't make a resistor, I have to make something that I can make in high volume with reasonable yield, so that I can deliver to the bottom line. And so those are, I'm trying to give you some very specific examples of what, from a business perspective, you might cause you to pause or think twice about doing a a chiplet. Now, again, these problems will be solved. They will be solved. I'm talking about a point in time, which is today. And there's a lot of learning for us to get to the point where we have mitigated all of this. Now,
so Tim,
oh yes,
I
please,
have a comment on here. So because I know they're gonna be, you said they're gonna be solved. The question is how they're gonna be solved. So if I look on how you address this from a business point, if you look at the short term,
yes,
the short kind of if your short term strategy and you're looking at a single product, there
yes,
is so much tiling tax that product will incur. But
okay,
the thing, if you look at a long-term strategy and how you
yes,
monetize the chiplet development for multiple product, I mean, I'm
yes,
speaking from experience because Intel, from a chiplet and chiplet adoption,
yes,
I mean, they did it because there are challenges, radical challenges. There is no reuse, there is no
yes,
cost addressed. So I wouldn't call Intel as a success story with the chiplet adoption. But then when you look at AMD, how they did their chiplet ecosystem, their
yes,
reuse, the cost, now it is beneficial for them to that they looked at it from a long-term
yes,
strategy than a short-term strategy.
yes, 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 yes. So, if I may paraphrase back to you, AMD from your perspective, what you're presenting is that AMD was much more successful at a chiplet strategy because they took they ensured reuse so that the investment that they were making in chiplets could get amortized over multiple programs, and it wasn't just looking at that one particular project and putting all of the cost and risk and all of that on one project. It got amortized over a multitude of projects, and therefore has been very successful. Did I?
So why won't that work in your company? To follow up on Sally.
Well, yes, good. That's a leads into my final point. So thank you for that. So generational reuse. Now, one of the circumstances that we face in our and I'm speaking a lot for our division, so please don't please be careful, because there's a lot of context around generational reuse that is specific to what we're doing in our data center solutions division. We are constantly what makes us do a new part? Well, there's a few things, but really what makes us do a new part is the next generation of, well, what would it be? DDR, more importantly, PCIe, more importantly, CXL. These standards have a cadence, and it's about somewhere just say on average, and some are faster, some are slower, but let's say somewhere between a 3 to 4 year cadence. And what that means is when we're doing a new product, we have a product line. So if you look at, we make, we basically make switches and controllers. That's what we do for a living. And we do four products that are all using the same generation of PCIe. We're doing them all at the same time. There's no reuse. I can't go back. Like I do a Gen 4 for product line. I don't go back 2 years later and do another Gen 4. I don't do that. I do a Gen 5. I don't get any reuse. There's no generational reuse there. Now, you can pick examples where, and I was speaking to Anu about this. There are some good examples of generational reuse, which would be extremely successful. So HDMI, for example. I mean, the HDMI spec has been relatively stable for a very long time. I believe, and I'm going to be wrong because I always get these things wrong, but let's just say it's 10 years. So, you can do 4 generations if you have an HDMI controller, and I know nothing about HDMI, so I'm just saying based, there are HDMI controllers out there undoubtedly, and you could very successfully have a chiplet strategy based on the stability of HDMI. Whereas for us, not so much. So that is one of the other circumstances that I think is a challenge for chiplet implementation. Now, I believe that is going to be addressed by the third-party availability, which is bullet number 3 on my list. In other words, other companies will take care of that for us, and we will be able to leverage all of their investment and making the current generation of whatever standards-based silicon, and then we'll be able to incorporate it. But until that's available, that's still a business challenge. And I think so. I've come to the end of my points. I just want to make a conclusion, sort of a generalized conclusion. And my generalized conclusion is, sorry. There was somebody in chat. There's some chat questions. Maybe we want to address those before. In fact, I can read it right here. No, I got it. Thanks for participation. There was these are statements. They're not questions. Okay, fine. So thank you, Dappy.
Tim, actually, I would like to drill more onto the third-party chiplet availability, because we're looking for solutions, right? So the third-party chiplet availability, that is still going to be hindered by a converged die-to-die. And again, I'm going to use AMD and Intel chiplet adoption as an example. So if I look at AMD, they have a single die-to-die. They took Infinity Fabric on package, and that's what they have across multiple of their product. If I look at Intel chiplet, there are multiple die-to-die. I have AIB, I have MDFI, I have bunch of wires, Foveros, PCIe. So that's an issue for reuse. So that's why kind of the chiplet adoption at Intel, because you have multiple chiplet with multiple die-to-die, product X cannot use what product Y is doing. So that's potentially going to be a challenge.
Yes,
if we don't.
And I agree with you. So one of the activities that I've recently started at the behest of BAPI is I've been participating in there's so it's a bunch of wires link layer working group for OPC, and we were talking about that link layer, which is extremely important for chip to chip from my view. And we were talking about packing. So it was TLP packing based on a variety of internal, chip level bus formats. So there's Chai and AXI and
hey, Tim.
Sorry.
I apologize. I'm going to. I want to save about 20 minutes for the next topic.
Oh, okay. Sorry, I got to conclude.
My bad. I apologize.
Or even less. You didn't tell me how long. See, I told you I would just keep yammering away until you shut.
No, I'm happy. But so wait, Marek, you have a question?
Yeah, I would have just one on this generational reuse.
If the questions are like absolutely, we don't get Tim often. So with Salam and Marek, please keep going.
So I guess coming back to this PCIe example, it sounds like you draw a distinction between using a chiplet in multiple products at once, which could already be like quite a good use for chiplets instead of like designing it 4 times separately and just having one tape out, and then like reusing a chiplet across generations. So would you say that at least like having, say, within one generation, just designing it once and then using it in multiple products is already worth it, or is that not good enough for you?
so the fundamental argument for the chiplet, probably, so you're talking about chiplet versus monolithic, and if I can get that PCIe interface into the monolithic part, it's the yield is reasonable because the die size is reasonable. It's going to be better for me to be monolithic, regardless of that. And in terms of the IP de-risk, I can do a test chip to de-risk the IP. So a test chip that just isolates the PCIe Gen X, and so that I can reuse it in monolithic and still have the benefit of having confidence in the IP because it's seen silicon.
Okay, so I guess then that all assumes that these like hypothetical 4 products are all sitting on the same node. So even though it's 4 monolithic tape outs, they can all reuse the IP in IP right. form rather than as a chiplet.
Yes. You're absolutely right. It's the assumption they're on the same node. Yes, and the interesting observation that we have is that as we climb in frequency in our I/O, the conventional wisdom says analog doesn't shrink, which is true. However, what's happening is as we climb in frequency, there is less and less and less and less analog in an actual SerDes, and because you rely on DSP to and what is DSP? Well, it's digital, and guess what? Digital shrinks. So I think there are perhaps it's very, very specific to our business and the nature of our analog interfaces. And so I would not want you to make that generalizations, because perhaps if you're doing, and I'm ignorant of this, so I claim ignorance, but perhaps if you're doing Wi-Fi, or perhaps if you're doing cellular, or perhaps if you're doing, I'm gonna think of another example, Zigbee or Bluetooth, that particular IP will not defy, or will not shrink with nodes. So there's no benefit in going to a smaller node if you're doing a Wi-Fi interface, because of the analog interface does not shrink appreciably.
Okay.
But that is not what we have observed, and so that is a critical, like one of the thesis of node separation is that, there are things that are easier to do in a larger node that are cheaper, and therefore you should use that. But in our circumstance, we're not finding that to be the case. And I think it's very specific to that type of analog that we're doing. Sorry, did that answer your question?
Yes, yeah, absolutely.
Yeah, I was just going to add to that. I think that.
Oh, sorry.
Yeah, could I just make a comment, because I know something about the SerDes space, right?
Yes.
So if you look at Gen 7, right, which is going to be 128, it's definitely going to need like 6, 5, 4 nanometer process, right? And as you say, the digital does scale, so you really save. It's not really the area, the power savings are pretty dramatic as well, right? But for the vast majority of other applications, though, I think the scalability argument is actually valid, like USB or lower performance I/O. So but specifically to the data center, which there's a lot of interest in the data center, which is the thing that's driving a lot of this chiplet strategy. I think that whether it's Ethernet SerDes or PCIe SerDes or some DDR, they're all going to require a move to a more advanced process. That's definitely factual, for sure. And I do agree about the third-party availability. And frankly, it's going to come from small companies. I mean, if you've ever tried to buy anything, let alone a chiplet, from a large company on a Friday and expect it, by the time you call up and they figure out who you talk to, and then do they even want to talk to you? Then some sales guy wants to talk to you, and then they'll figure something out. There's a real world out there, as you know, right? And so it's going to be smaller. I'm convinced that it'll be smaller companies that have to do the third-party chiplets. They actually have to make it foundry direct or them selling it, so that it becomes easier to use, right? As opposed to imagine trying to buy a chiplet from AMD, right? It ain't gonna happen. I tried to buy an FPGA from AMD, and it took us 6 months to even get a response on the universal stuff because they're so hard to get, So there's a lot of. I really appreciated your points, by the way. I think that within this group we have this sort of ivory tower approach, which is everything. I just do it and it's going to happen. It's not quite that easy, right? So, yeah.
Yep. Big companies do all of that. So I completely agree with you in terms of sales cycle, qualification of customers, so on and so forth. It's a very
but how, if you follow Kash's argument about a small company going to provide the IP, how typically big companies don't like relying on small companies as vendors for stability, and how does that bridge get crossed then?
Yes. So I would dispute that. Big companies often rely on small companies for solutions. I think the reality, you need to think about the startup universe, and so this is not specific to chiplets. It's just my editorial on startups. So every startup, for every startup there's 100 unsuccessful startups for every successful startup. And so a lot of startups go and I mean, if you're in a startup, one of your driving goals is to get a design win with a big company, because that, for all sorts of reasons. So everybody's trying to do that, and so the general experience is, oh man, those big companies, they never do business with little companies. Well, no, that's not true. They don't do business with unsuccessful startups, or they don't do business with startups that. There are many startups where they've gone around and they kicked the tires, but they discarded them. But that doesn't mean to say that they don't do business with startups. I think to me it's an artifact of the fact that there are so many startups. Many will never be successful, and so the perception is that big business never does business with startups. But I would dispute that.
Yeah, no, that's obvious, right? I just think it is going to be the smaller company. I mean, you look at Tesla, right? If they had tried to sell Tesla cars through a dealer network, right? I mean, even the big companies are finding that selling electric cars through the dealer network is a total disaster, because you just can't get a price. You can't get your questions answered, and you just say, to heck with it, I'll buy a Tesla, right? Because and I think the same thing is going to happen with a chiplet. I mean, if you take a chiplet, and I mean, just think about this, right? You sell somebody the chiplet, well, that's not enough, right? They want to be able to test that chiplet when it goes into an end device. Is AMD going to give, or Intel give you the test vectors? I mean, how is this really going to work, right? When you've got 8 different chiplets on a. So there's a lot of things that I don't think anybody's really talking about when they talk about business challenge.
So to your point, I believe. So, sorry, go ahead.
No, I do want to save about 10 minutes for Marek. I apologize, Tim.
Okay, well, listen, cut down the long and the term is, I believe all this is going to be addressed. I'm very confident in the chiplet feasibility and viability and success. I believe that initially it'll be very specific to application, but it will move to general use, and the reason that is because of the Moore's law is stalling, and this is an excellent way to get around that. So thanks very much for everyone for listening to me. If you have questions, please email me, and turn it back to Bapi. Thank you.
Yeah, thanks, Tim. Actually, I want to just add a point. I was following Cash and Tim conversation. I think the question that we need to address is who's going to be adopting chiplet. I think 90% of semiconductor companies, they were not going to rely on third-party chiplet to be available. Potentially only 10%. I think if I look at some of the Mac customers, some of the DIP customers, low volume, those are the one that will need these third-party chiplet more than big companies trying to rely on third-party chiplet. I think there's enough analysis that was done and I've seen that alludes to potentially that fact. So I don't know if you guys have seen kind of same analysis from a business
No, actually, if you have that,
perspective.
please share. That sounds really interesting. Please do share. Please share that if it's
Yeah,
publicly available.
Bobby, maybe I will have. I mean, if you have a slot, it doesn't have to be in March. I would like to bring potentially the chiplet from Intel perspective because it's kind of maybe a non-successful approach for that, and what we see from business push as well. So I can present
Oh,
few
fantastic.
slides
I
from
will
an
slot you
Intel.
in.
Okay, thank you.
Tim, that was wonderful. Thank you.
Pleasure.
I took a lot of notes. So
I'm going to stop sharing now and turn over to our next speaker. If I can figure out how to stop sharing.
that's okay. I think Marek can. So Marek has some plans on how to move this discussion forward in the business group, and we're just going to keep hitting them for the next few weeks. So Marek, it's all yours.
Sure, sounds good. I have like one slide with my ideas if you.
Oh, hang on.
Oh,
then let me make you presenter.
No worries.
Somehow Tim managed to grab the screen without me making him a presenter, which is like quite the feat.
That is interesting. So
Yeah.
as Bobby had mentioned before, one of the challenge would be to like, now that we have heard from so many companies already and are going to hear from a couple more, to like make that information useful and digested in some way. And so here are like two ideas for the ODSA business working group, what we could be doing. And the first one would be towards analyzing the discussions that we've had on business challenges. My idea would be that we try to identify common themes on based on what we've heard. And then a good way possibly would be to summarize those information then on business challenges in a white paper. So that would be one of the objectives that we could work on. And I think once we have all of that information, it would also make sense to plan on or to think about which of the challenges that we've just identified can the ODSA help address, because I'm sure it's not going to be like we won't be able to fix all the issues. So maybe first, do people have thoughts on that?
So we'd be looking for participants in
Yes, exactly.
these efforts. So Cliff,
yeah, is anybody interested in helping out with this?
Can you lead off with any thoughts on this idea, on idea one, please? Oh, Tim likes it. Okay.
Yeah, I'll volunteer some time.
Excellent. Cliff, if you're speaking, you're still on mute.
Actually, I wasn't, but I will chime in that I think it is a good idea. I think that there's been a lot of issues identified here because we've all been sharing in a very open environment. And I think capturing that and documenting that for the rest of the world would be very valuable. I'd really like to see it go to the next step, where we have two very key problems that we want to solve. I don't know which ones they would be yet. I mean, to me, what I heard a lot of was chiplets become economical when there's reuse across product lines. And today, there's no real model or modeling or examples of how that could work inside a company. So as just one of the areas that I heard about that I really love to see a follow-on work around that. Perhaps that will come out of this white paper. Another area I know we heard a lot about was the concept of what are some very specific, what are the 5 or 6 standard form factors that people might use for chiplet interconnect, and a guide for people that are going to do this, system and package creators, to leverage the knowledge of people without anyone giving away their IP, but enabling sharing of chiplets is another thing I heard a lot of big problems around. So just some ideas of where I'd like to see an outcome past documentation of the ideas or of the issues.
Okay, yeah, no, that certainly makes sense.
And Marek, for the first items, we have to identify low-hanging fruit, because when you look at the challenges, once you do the digest, you'll see a bunch of them. There are some challenges that are important, and they're low-hanging fruit that can be addressed first. So criteria, because if there are other challenges, maybe you're going to pick up 2 or 3 challenges that ODSA will help with. But the other challenges need to be solved. We cannot undermine any of the challenges. So maybe potentially a phase process. Maybe phase 1 will do this, phase 2 will target this, phase 3 will target that. So potentially it's not to drop some of the challenges that some company highlighted.
Yeah, I like that. And I'd also hope that we can put together some sort of timeline for addressing a couple of these. We know we have some milestones around Global Summit in October, and it'd be really great to have some novel work made visible there, which we can.
Okay, yeah.
I think it's a great idea. Now all of you know what I face at work, right? And Tim is the nice version of it.
I feel your pain now, Anu. I'm just kidding.
Thank you so much.
Okay, yeah. So I guess what Cliff, what you're saying would be maybe to like even if we haven't necessarily finished like addressing some of these challenges, at least to have a plan on how to address them, and have a method on how to move forward with this.
That would be helpful, because then we can look at how do we make it happen. Yeah,
and I guess I like the idea of once maybe that information is structured in a way, and we've already with the I like Salem's comment on the low hanging fruit. If we have kind of an order based on how important they are and how easy they're to do, and we pick something that's important and easy to do, then at least that would be a forum to also ask for more help, or bring this up to a broader audience and hopefully get more help than solving these issues.
Right. If we do have that and we're advertising that we're looking to have some work streams going on these areas, then we can do an outreach to the members and the community and try to get people to join. Yeah.
Okay, that makes sense.
Hey, Marek. Please save the item 2 for next week. I think we'll be coming back to this week after week. So the other thing that we want to have everybody think about is a time for when to meet. Previously, the business work group met at 9 a.m. on Fridays, immediately after this meeting. But does that continue to work? But I guess we need participation, right, Marek? That's one thing we're looking for. So that's basically it. Marek has volunteered to drive some of this. And so anybody else with any thoughts? Because we could definitely use a lot of participation.
Yeah, and then maybe whoever is interested, I could then reach out directly and see what time would work for those people.
Tim,
yeah, I'm interested. I'm interested, but 9 a.m. Friday, it's always a
yeah. So
at least on the West Coast, that's a tough time. I know I guess that's your lunchtime, right, Marek? So
yeah, exactly. No, I mean, I'm also not sad if this would move 1 hour past.
Yeah, I think I'm interested in participating. Why don't we just get the names of the people who are interested in starting, and then we'll figure out a time that works for people.
Yeah,
that's probably the best way to do it.
Think about it. I think we're going to deserve 10 minutes for this discussion every week for the next couple of weeks so that we can all round up participants.
Yeah, I do also have to drop like right now, basically. But let's continue this discussion next Friday then.
Tim, thank you.
Right.
Marek, thank you. Kash as well, and Selim for a very active discussion. Thank you all. Hey Selim, I put you on Selim. I put you on 4/7, I think, tentatively.
That sounds good.
All right.
Hey, Bapi, can I do something on 4/7 as well for my new company? So,
Sure. So,
is there space?
yes, or I'll give. But how much time do you need, Selim?
20 minutes.
Okay, then yes, then absolutely. Otherwise, as Kash, I was going to put you the week after or the week before, but then 4/7 works.
Okay.
All right.
Salam, if you need more, because I think a lot of people will be interested in Intel. Okay. So.
Oh, I know. I mean, 20 minutes will
yeah.
be the slides. Maybe there's going to be a lot of.
Yeah.
Kash, why don't I put you the week after or something like that, or the week before? Let me look.
Do the week after if possible. Then.
Do the week after. Okay, I'll do that.
Yeah. Okay. Because I will have a lot of questions, right? So because I think hearing from people who are really fighting that battle is really, really helpful, right?
Exactly.
So it's important. Yeah.
All right.